A common misconception students may face is when they focus on the ending point of a ruler rather than the length. Without attending to where an object is aligned on the left side of a ruler, students read the number on the ruler that aligns with the object's right edge. To help this, an activity that could be used for students is to move items along a ruler and ask students if they believe the item has changed size. Iterate units to show how long the item is, and then show how those units match the units on the ruler. This will help them realize the length of the object depends solely on the object's length, not where it's placed on the ruler.
This misconception is when students place multiple individual units with gaps between the units or with some of the units overlapping. As you can see below in the picture, it shows a student overlapping units when measuring area. To overcome this problem, the activity that I found was you could give students thick units or units that are thicker that make overlapping more difficult. They can utilize plastic square tiles or pattern blocks to avoid overlapping when measuring units. This activity is for second grade, and the technique that applies is students use concrete models as square units to find the area of a rectangle by covering it with no gaps or overlaps, counting to find the total number of square units, and describing the measurement using a number and the unit.
My common misconception is counting tick marks instead of units. So this misconception is when students that may be measuring objects would count the tick marks rather than the actual units. So counting 1, 2, 3, 4 instead of 1, 2, 3, 4 inches or centimeters or whatever it may be. And then below is an example of the from the book that shows that the students are in fact measuring the pencil, but they're measuring it by just the tick marks and not lining it up on that 0 and measuring it correctly using units. And one activity that you could have your students do is first, of course, teach how to use a ruler and how they should line it up and like correct measuring topics and objectives. And then once they get that down, then you could give each table group certain objects, and the students can work with their partners to measure the objects using the ruler and making sure that they're not counting the tick marks and they're actually counting the units. And then this is a first grade activity, and listed below is the teak.
This misconception is when students measure perimeter using only 2 sides. And for the grade level, for the activity, you'll see in a second, I put 4th grade math, and the teaks connect to using models to determine the formulas for the perimeter of a rectangle. And then an activity that went with it that the textbook provided, and I did a little illustration at the bottom about it. It was have the students highlight the perimeter or draw around the sides. And I said this will help them physically trace each side of the shape. With this, they will gain a better understanding that the length of every side contributes to the perimeter. And this goes along with the teaks that concern using the correct formulas for perimeter, because students have to go and trace each side, and that relates to the formula to find the perimeter.
So the misconception that I want to talk about is cutting a shape into parts and rearranging the pieces changes the area. So for this misconception, the students don't understand that if a shape is constructed using the same size and shaped smaller shapes, the area of the two shapes, even though they're different and one might seem bigger, they're still the same. They're the same area. And so the techniques that I used for this was decompose two congruent two-dimensional figures into parts with equal areas and express the area of each part as a unit fraction of the whole, and recognize that equal shares of identical wholes need not have the same shape. So an activity that I would use is have the students use small shapes that are the same size and same color, just to take away the confusion of the colors, and they would use those shapes to form their own three different shapes and then trace over them, and then have the students just really understand that they were formed with the same shapes, and even though they're different, they still have the same area.